All right, let's try a few examples now. Take a look at this first equation here, and you'll see that it is x squared minus y squared. So since the x squared is first and x goes left and right, we know that the hyperbola is going to open left and right because x is first. All right, the center. The center is whatever is added to x and y. There's nothing added to x and y, so the center is at 0, 0. So I'm going to graph that. The vertices. We are going to find these by using the numbers that are under the x and the y. Since x is first, that's how I'm going to find my vertices. So this is really a squared. To find a, I take the square root of that, so the square root of 9 is 3. So that means I'm going to go left and right 3, and that's going to give me my vertices. And I go left and right from the center. So if I go left 3, that puts me at -3, 0. And if I go right 3, that puts me at +3, 0. So there's my vertices. My co-vertices, and I'm not asking for these, but we still need to put them on there. The co-vertices we find by looking at b squared, which is under the y value. So the square root of 36 is 6, so we're going to go up and down 6 from the center. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And again, this is just going to help me find that rectangle in order to make the asymptotes. So we make a rectangle out of this. This is not part of the graph. This just helps me find how wide or narrow the curves are going to be. From here, what I'm going to do is I'm going to make asymptotes. So I go from the center to each corner. So there's an asymptote. I'm going to turn my paper so I can do this. Here's an asymptote. And so there's the asymptotes. Now, to find the formula for the asymptotes, and really watch, because sometimes I'm going to want the equation of the asymptotes, and sometimes I'm only going to want the slope. And it's just going to depend on what makes it easier. So since it crosses at 0, 0, it's easy to find the equation of these. So think, we went up 6, and we went over 3. So y equals mx plus b. The slope is up 6 over 3, rise over run, plus b is 0, it crosses at 0. And I do want these simplified. So 6 over 3 is 2, so my asymptotes are y equals 2x, I'm not going to put plus 0. And then this would be up 6, left 3, so it's going to be plus or minus. We've got a positive slope and a negative slope. All right, so there's the asymptotes. I'm not forgetting about c, I just haven't done that yet. To graph the equations, remember x was first, so I know it's going to open left and right. So I go from my vertices here, and it's a really open, a really wide hyperbola here. These curves, if it would have been y squared first, then they would have been a little bit more narrow, because that's a little skinnier there. So there's my hyperbolas. C is going to help me find my foci, my focus points. So in order to do that, I do the a squared plus b squared equals c squared, which looks like Pythagorean theorem, but it's really not. So a squared plus b squared equals c squared. That's c. A squared was 9 plus b squared was 36. So that's going to give me 45 equals c squared. Square root. Square root of 45 is actually 3 radical 5, or about 6.7. So my c values would go over 1, 2, 3, 4, 5, 6, and then some, and both ways. Those are the focus points, and they're further away because this is so wide. So if I just want c here, it's going to be 3 radical 5, or 6.7. Again, really read directions to see if I want decimal answers or if I want exact radical answers. Okay, let's try another one. Okay, if you look at this one here, we've got a little bit of an issue. This one is not equal to 1, and our standard conic form is always going to be equal to 1. So make sure it's set equal to 1. I don't know why I put a 0 there. Set it equal to 1. So I'm going to divide everything by 16 to make sure that it's equal to 1. So this is going to simplify to y squared over 4 minus x squared over 2 Now I'm in my standard conic form. All right, since y is first, that's telling me that this is going to open up and down because y goes up and down. My center again is at 0, 0. So I've got a center at 0, 0 because nothing was added to the x and the y. If it would have been added, keep in mind the x was first. That number is going to correspond to your h value of your center. Whatever's with the y is with the k, so just be careful. So to find the vertices now, we're going to go up and down. So this is my a squared. A is equal to 2, so I'm going to go up and down 2 from here. So I'm going to go up 2, and I'm going to go down 2. Don't make the curves yet because we don't know how wide or narrow they're going to be. Now I need to get, my box here. So b squared is 2. So b is actually radical 2, or about 1.4. So I'm going to go over left and right, about 1.4. I'm going to make this box, this rectangle. From there I'm going to make asymptotes. And the asymptotes are what's going to actually help me find how wide or narrow these curves are. So there we go. Now remember, at this point you want to remember that the y was first, so it goes up and down just like this, and go from the vertex. Some people accidentally will go from the center. You always go from the vertices. And there's my hyperbola. All right, so I never wrote down what the vertices were. The vertices were, I went over 0 down 2, and I went over 0 up 2. Don't forget to fill those in. All right, so the asymptotes we found here, remember we went up 2 and we went over radical 2. So we went up 2 and we went over radical 2. We can't leave it like that, so I'm going to multiply the top and the bottom, numerator, denominator, by radical 2 to get 2 radical 2 over 2, which those cancel out. So my asymptotes, my equation, is y equals plus or minus, because I've got a positive and a negative, plus or minus radical 2x plus 0. I'm not going to put plus 0 though. So that's the equation. If I only wanted the slope, you would just tell me plus or minus radical 2. All right, so I still need the foci. To find c, what I'm going to have to do is that equation that looks like a Pythagorean theorem, a squared plus b squared equals c squared. And again, I always just remember that if the equation has a minus in it, then I'm going to do plus with this a squared, b squared, c squared. If it was an ellipse and that was a plus, then that would be a minus there. It's always the opposite. All right, so here I've got, look at your simplified ones. A squared and b squared are 4 and 2. 4 plus 2 is 6. And if I take the square root of 6, I get about, let's see, it's radical 6, which is about 2.4. So from here I would go up 2 and a little bit, down 2 and a little bit. So my c value is either radical 6 or 2.4. Again, it's going to depend on what I'm asking for, if I want it in an exact form or if I want a rounded form. Let's try one more. All right, so here, this time I've got it set up for you. I've got it in that standard conic form because it's equal to 1. So I can just start doing the work here. All right, so the center is going to be, first of all, let me back up. The y is first, so since y is first, we know that this is going to open up and down. Be careful. The biggest mistake people make with the center is they'll automatically look at the 4 and the 3. But be careful because the x is over on the right side. So my center is going to be -3 first and then -4. So you want to plot that point, go back 3, 1, 2, 3, 4, right there. All right, to find the vertices under the y, I've got 4, that's my a squared, so a is equal to 2. So that means I'm going to go up and down that far from the center. So go up 2 and go down 2. Those are my vertices. So let's figure out what those are. You can look at the graph. So it went back 3, down 1, 2, 3, 4, down 6. So -3, -6, and -3, and that went down 2. Or mathematically, you could have just done the x is going to stay the same, only the y is changing, so you would add and subtract 2 plus minus 2 to your y value. So if you want to do it that way. All right, then I need to figure out how wide this box is going to be. So my b squared is 9, so b is equal to 3. So I'm going to go left and right 3 from the center. 1, 2, 3, 1, 2, 3. And I'm going to make a box out of that, a rectangle, in order to make my asymptotes. You can't see that color very well, sorry. Let me switch. All right, so here are my left, right. Here's my rectangle. So then what I'm going to do is I'm going to make these asymptotes from the center to each corner and make them long enough so that you can actually make your hyperbolas look fairly accurate. To remember if it's going to open up, down, left, or right, go back and look at this. It was y first, so it's got to open up and down from the vertices. And this one's going to be pretty wide because of where the asymptotes are. All right. Notice this time I'm only asking for the slope of the asymptote, and that's because the center is not at 0, 0, just honestly to make it easier for you. So you went up 2 and you went over 3. So the slope of the asymptote is going to be 2/3. It's going to be positive and negative 2/3. C, in order to find C, we're going to do a squared, let me do this out here, I'm going to do a squared plus b squared equals c squared. So I've got 4 and 9 for a and b, a squared and b squared. So c squared is going to be, sorry, c is 13, radical 13. Or if you change it to a decimal, it's about 3.6. So from the center, I would go up 3 and then some, and go down 3 and then some, so I'm a little bit off the graph there. All right, so that's how you graph a hyperbola.